Okay, so I'm going to enter a problem here. I have Alice and Bob, the two client servers, set up. This is the server desktop. So let's enter the third order polynomial, which is going to run from 4, 5, 6, 7 are our coefficients. And it's going to run from 0 until 45. And the differential 1/10,000. Okay, so now it's completed the problem and it's ready for another one, but let's examine the one it did. So the answer it got is the integral you calculated is statement, and it gives us the value of 7,363,562. So 7.3 million. And this one is the same integral computed on my calculator, 7,363,586. 7363 and 3 others. 7363 and then 3 others. So it's really close. I mean, it has 5 accurate digits there. Okay, this is on the server end where it has sent the work to the client servers, done some of the work itself, and then recombined the results. A demonstration of a hybridized client-server architecture, whereas this server contains most of the power and the clients don't. And it's shown how you can distribute work among computers. But for those of you who are skeptical and somewhat scientific about this, I am now running this program on multiple different computers, Alice and Bob. So let's go over to Alice here. And as you can tell, sorry about the mess, we were still moving between multiple apartments and houses. This is Alice, and as you can tell, I've done 2 integrals with Alice. So it's given 7, 6, 5, 4 are coefficients in the polynomial, whereas this is the constant x term x squared x cubed, and it's ran the integral from 22.5. It ran it from 0 to 22.5 with a differential of 1/10,000th. And Alice has computed for us this partial sum here, 472,000 some odd. And now let's go over to Bob. And I'm sorry for the noise, but Bob is this computer right here. I've named this one Bob, and it's gotten the same calculation, 7x cubed plus 6x squared plus 5x plus 4. And it's going to run starting at 22.5, run the integral for a length of 22.5 after, which will bring us up to 45 with a differential of 1/10,000th, and it gives us this number, 6 million. Here we go, 6,890,915. And so both of these were sent back, so memorize that number, to the server and then combine. So right now, sorry, I will show you the final piece. This is the same code as the first video I posted today, and you can see this is the one that Bob sent, and that's what Alice sent, and it combines them together to give you this. So it's basically a demonstration of distributed computing. And just for completeness, let's look at the actual code for the server is here. So basically how it works: wait for at least 2 computers to join, connect with them using the socket statements, enter the polynomial using Easy GUI, then distribute the problem, send it to the client servers, wait until they get back, compute the results, combine the results, stop the program. Well, that's pretty much it. Just for the sake of completeness, let's go back to the idle shell and enter one final polynomial. So let's enter basically a triangle. So first order problem with an intercept of 0, a slope of 37, and we're going to run it from 0 to 15 and a small differential. And so it's connected with Alice and Bob yet again. It's ready for another calculation here. I've modified the program from yesterday, so it's able to do multiple calculations in succession. Okay, well, we know that, we'll look at the answer in a second, but we know that if we have a triangle, it's half times base height. So we ran this from 0 to 15, so it'd be multiplied by 15, then multiply that by the 37. Where did I mess this up? I'm sorry, I forgot the number I entered a minute ago. Let's do this again. So if we enter the first order polynomial, enter the order of the polynomial to first order, which is a line, and we're going to enter the constant term, which is nothing. The first order term is 31. Okay, so let me enter that in our calculator here. 31. And the second order term is going to run between 0, it's going to run up to 15. Small differential. Okay, actually I think I found the mistake here. We have to multiply 15 squared on this because the height is actually 31 times the final x value. So it comes up with a figure 3,487.5, and we get very close to that, 3,487.54, and that's the round off error from the fact we're computing it. And it sent this to Alice and Bob. So I've proven it does integration more or less accurately numerically, and it divides the code and the work between several client servers. Now, this isn't strictly a client-server architecture, because in the official sense, the server should do all the work and respond to the clients. But the clients communicate with the server here, and the server computing a long list of summations is inefficient. It's inherently unscalable, as was mentioned in lecture, and it's easier if the clients do some of the work. The only thing the clients send to the server besides requests is the partial answers as shown. So this is a demonstration of how distributed computing can be performed in a simple sense, although the concept can be brought to an arbitrary scale. And this is sort of what SETI did when it was looking for artificial intelligence and dividing, not artificial, alien intelligence from radio signals, and was dividing the work and conquering. Anyways, I hope this was enjoyable. This is an adjunct to my previous video for those who are skeptical and wanted to see it run on 3 differing computers. Thank you for watching.